Sagar bhai, video.
Yeah, I've just started this, and hi everyone. Thank you.
Can you pin the? Carry on, Shreeji.
Sorry, I was just saying that hey everyone, thank you for joining the design and feedback call. We're doing, I think this is the third one that we're doing. We've already done about 10 to 12 prototypes before this, where we've sort of, collectively all of us have given feedback to the different designs. So today is the third call, I think, in the session. We're doing this every Monday and Thursday noon, so that we are all in our labs so that we can see it. So we're going to start with Priyank today, and then get to the next couple of prototypes.
Richa, can you pin the video of Sagar Sujitra so that my video is not coming in everyone? I'm not near the model, that's why.
Yeah, I'm done. Yeah, pinned. Go ahead.
Okay.
Yeah.
There are two videos in the system. One is Shreeji iPad and one is Sagar Sujitra. Both of them are showing my model. So let me get straight to the point. Whatever we are using, these are aluminum sleeves, professionally made, 80 mm bore and 500 mm length. Sagar bhai, on the back side. On the back side. So, two zeolite sleeves, both containing AGC chemicals, 0.4 mm to 0.8 mm sodium-based zeolite. I'm getting good results in this. At this point, you can see there are two copper coils connected to my system. One is connected to the one is connected to the Sagar bhai. Mute. You are mute. Sagar bhai, you are mute.
Shreeji, you're mute, I think.
Shreeji, Sagar bhai.
You're on mute.
Okay. Yeah. Now I'm audible, right?
Yeah. So can you go near the compressor, the air tank compressor?
At the compressor?
Air tank compressor.
Okay. Right now we are using two different compressors. One is we are using direct compressor, when another one is attached with the tank. So we are putting down pressure from two different compressors.
And basically, this is something that Krishna from Hyderabad suggested. I had a talk with him yesterday. We were getting, I guess, 96% at 3 LPM for 24 hours continuous running almost. We were running it continuously, and it was almost at 3 LPM and 95-96%. Then as soon as I start increasing the flow rate from 3 to 4, it drops to 85-87. And as soon as we go to 5, it will go till 78-79. 79 is the least which I was getting at 5 LPM. So this is what my setup was. I'm using 1.5 HP Betali compressor, as well as GH750 from GAL. So these are the two compressors which I'm using. I'm not getting any issues if I'm using both of them in parallel. I'm getting Sagar bhai, can you go to the orifice area? The orifice.
Just 1 minute.
Yeah. So I'm using it from both the things. One is from the orifice and as well as NRV. I was getting good results in NRV, but as soon as I shifted to two compressors, I was not getting good results in NRV. So I had to shift to see. If you see, that's how it is on NRV. Two NRVs are connected. And that NRV, both the NRVs are from the PSA sleeves, and then they are directly going into the oxygen cylinder. So this is this is the result which we're getting in both the things. One is 1.2 mm orifice as well as NRV. In both the things, we are getting perfect results. Now, as soon as we increase from 5 to 6, now after two compressors with 1.2 mm orifice, I'm getting a drop in oxygen concentrator till 85-86. So I'm not going beyond 6 LPM. This is the highest which we are able to get. Second thing, I'm using two-stage moisture separator. One is the heightened one. We were almost able to, we had to remove moisture every 10 to 15 minutes. So that is some issue which we have to solve, that every 10 minutes we had to open the valve and remove the moisture. And that moisture was a significant amount. Our hands were getting wet. Whatever we put in the bottles, there was some moisture. So we are able to capture a lot of moisture. There is no moisture at this point going into the zeolite. I'm very sure of it because I've used transparent tubing, and all the transparent tubing, there are no moisture after the moisture separated. Second issue which I'm facing is there is a huge difference in flow rate. As you can see, the small one, there is a small flow meter. Sagar bhai, can you show the flow meter? This is basically a flow meter that is used in commercial oxygen cylinders. So I'm using this oxygen for flow meter, and this is showing almost 10 to 12 LPM, whereas the oxygen concentrator, oxygen analyzer from USA, the forensics one, which I am using, that shows only 5 to 6 LPM. So this is something which I mentioned in last night's meeting, that there is huge difference in the flow meter reading. So if I consider this flow meter, which is used in commercial oxygen cylinders, then I'm getting pretty good result, because at 12 LPM, I'm getting more than 90%. But if I change this to the oxygen analyzer flow meter, it is almost 5.5 LPM. So this is one thing I wanted to ask the people. Second thing which I'm facing, and which I guess would be solved by using in PCB, I'm getting absurd restarts of Arduino. Basically, at any point of time, when the switching is happening, that cycle stops and it restarts. And that is issue. And that point of time, I'm getting a drop of almost 5 to 6% in oxygen. Then again, it restarts. Then again, it is an increment. There may be some issue with the maybe Arduino system, but I'm not sure. So that's why from today we are designing a new PCB in which all the connections are perfectly done. So these are some things which I feel that there are issues in my system. Second thing, I will show you. I will tell you my compressor, basically the PSI ratings. At this point, the compressor rating is almost 50 to 55 PSI. That is the pressure which I'm putting inside the system. The pressure regulator is keeping it at 30 PSI constant. I have set it to 30 PSI. If you can see, the system is currently on, and the pressure regulating pressure swing is between 30 PSI to 30 PSI, and it is maximum going to 30 PSI, 28 to 30 PSI. And I'm getting almost 27 PSI pressure in the oxygen surge tank. 27 PSI in oxygen surge tank, 28 to 29 PSI in PSA tanks, and the compressor tank is working at 50 to 55 PSI. This is the system which is working at this point of time. Now, any specific questions or any specific inputs, we can try and do it. But I am at maximum 6 LPM at 95 or 96%. That is maximum. Anul, maybe Anul, Gorba, or Vaibhav.
Okay, so I think at this point, what we have is measure the input LPM. So if there's any way to have a high flow or rotameter, where you can measure how much LPM is going inside your system.
So is there any specific device which you can use to measure the input flow meter?
Same as the output flow meter, except this one I'll have to be at least like 200, 300 LPM. Because
Okay.
my suspicion is that the compressor is not able to supply the LPM required.
Okay.
One can go beyond 6 LPM on the oxygen.
Okay.
So we have to verify that, I guess, is the input flow coming from the compressor.
Okay.
The other thing is maybe compressors are not rated for high flow. So even though they may generate pressure, eventually what's important for us is to just have the amount of flow going inside the sieve tank.
Okay.
So I think measuring flow is the input flow is a bit important at this point.
Okay.
That's one. You said you're using aluminum sieves.
Yes.
Is it with lithium or with sodium? Sorry, I missed that
With
part.
sodium.
Sodium. Okay.
So yesterday
Yeah.
I had mentioned in the meeting, you can see the Shreeji iPad is showing you the exact. This complete set comes into that amount. The amount which I mentioned, 7,500. The upper
Okay.
and the lower plus the cylinder plus the side one. Everything is included into that.
Okay. And how much weight of zeolite does it hold? 1.5
It's
kilo?
almost 1.4 kgs in each.
1.4. Okay. All right.
And second thing is, I'm not, so what is the second step to remove the moisture? I'm able to capture the moisture. But what about removing that moisture in an automated system? If you want to make it in a hospital manner or the way Vijay Varda has made in Fractalworks, how do you remove the moisture at some intervals? Because I'm able to capture it.
Yeah. So what we're doing here is a combination of copper coils for cooling, of course, after the compressor. But we are going to try a chiller mechanism and another, let's say, it's sort of a radiator mechanism, just using fans. So no coolant or anything. Just an
Okay.
evaporator coil with cooling fan. So that's something we are waiting for. I think today or tomorrow we should be able to try it out.
Okay.
Of course, after that you need the moisture separator, and then we are also using a sieve for desiccant, a desiccant sieve.
No, I'm not saying that I'm not able to capture the moisture. I'm able to capture the moisture in the heightened one. But how do
I
you
get it.
remove it?
Yeah, so we'll have to do two-stage separation, primary and secondary.
Okay.
So major part of moisture is separated by using copper coils and moisture separator and all that. And after that, whatever is remaining is removed using a desiccant.
Okay.
The plan, I guess. So with desiccant, one of the other things we're going to try is put some desiccant inside the main zeolite chamber itself.
Okay.
Use the same pressure swing cycle for removing moisture as well.
Okay. And second thing is I'm not sure why is this happening. When I'm using the NRV, I'm getting almost 20 to 25 psi into the oxygen surge tank. But when I'm using orifice, I'm just getting 7 to 8 psi.
Yeah, that's expected, right? Because it flows back into the surge tank, into the sieves, I guess. So, yeah, I think that's expected, I guess.
So, what do you suggest? Using an NRV or a orifice?
Since it's sodium, I think it's better to use the orifice as in the original oxygen.
Okay.
They're using both,
And
right?
no, we are not using both. I'm using
No,
just
but
the NRV.
we're using both. Because
Okay.
if you think about it, the orifices will lead to creating a higher flow because it's restricting.
Okay.
Sorry, will lead to a higher pressure, right? Because it's restricting the flow.
Yeah.
And then the
So
non-resolved
basically,
valve
NRV
makes
is,
sure that it does
NRV is
not come back.
creating higher pressure.
Huh?
NRV is creating higher pressures into the oxygen surge tank, whereas orifice is just creating 10 or 12% of the 10 or 12% of the.
So if you think about like logically what orifices will do is because it's restricting the flow Bernoulli's principle right there. So it's increasing the pressure, right? And then what's going to happen after that, after the orifices, if you install a NRV, the NRV will make sure that none of what has gone forward comes back. So the NRV will increase the pressure inside the surge tank, and that's important. That should be there, is what Anul and I think for sure. The orifices will lead to pushing that pressure out and increasing the pressure over there.
So you are saying first
in the post side.
then the first the orifice and then NRV, right?
That's our system, correct, Anu?
No,
Yeah.
Hello, Pace bhai.
we have direct output actually.
No, we
Yes,
have
sir.
orifices, and then we have a NRV before the surge tank.
Yeah, but
So basically, Sagar bhai, 1 minute. Basically, it's orifice on both the PSA tanks and NRV on the basically oxygen sleeve tank, right?
yeah, that's right.
Yes.
Okay. Okay. We can try to do that. Yeah, one of my yes, Sagar bhai. Yeah, tell me.
Yes, we have input flow meter at the input side, and it's right now above 25 pm. As sir has said, you have to measure the input flow, right?
So input
That's
flow
around
is around
20.
almost 25 LPM only.
Because our system, we have only 25 LPM flow meter, and it is going up to the maximum. You can see.
So then we need to go for a bigger flow meter. This is the biggest one which we had.
Yeah.
And one more thing.